Hi all. Can you hear me?
Thanks.
I missed that.
I can hear you.
All right, great. Make the volume louder. Oh. Okay.
Seems like we see that incident from so many different angles. All right, Gabe, thank you.
Arshaf, please mute if you have something else going on in the background. Okay. Give everybody like a few more minutes to connect. We only have 13 people, and then for a minute or two, since it's the first day. Okay. All right. We'll begin. One more person. Okay, great. All right. Welcome to the summer course for Physics 120. This is introduction to calculus-based physics. We'll discuss the Newtonian laws and in general mechanics, so how rigid bodies move in our universe. And this is calc-based, and actually you need calculus to describe motion of objects in our universe. That's actually why it was developed. And it's not too difficult. So should have all taken calculus before, and so you should know how to calculate derivatives and integrals and maybe some limits. And generally for physics, we will discuss the conceptual nature of derivatives and integrals and what they are actually used for as part of the course. And now we will stick to simple integrals and derivatives. It won't be very complex, but it's the conceptual basis for these quantities are more important. And we'll be spending time on other things as well, of course. We could begin. Okay, so the course will consist of lectures and And these will be synchronous and asynchronous. On some days I will have other meetings and I will just post mostly asynchronous videos. We will do synchronous videos as much as possible where we're in the Zoom chat room. What I find with the summer course is that 2.5 hours is a very long time to sit in a lecture. So just for our own energy levels and concentration abilities, we will try to do about an hour and 40 minutes of lecture, and then I would post the rest as an asynchronous video. All the lectures will be recorded, unless there's some mishap with the recording features, but they will be recorded and posted on YouTube, and I will share a link, a private link on the Blackboard page. So just look for the links for the lecture after class. They're recorded through the Zoom chat room, and currently there's a 40-minute limit on the Zoom chat room. Once the limit is up, they'll kick us out, just reconnect to the same room, and we'll begin. I like to keep it at the 40-minute limit because it sets a time limit on the videos. So the videos will only be 40 minutes and it's easier to reference. Like I said, we'll try to do as much synchronous time as possible. There's a few days that we'll probably do mostly asynchronous. June 16th will be one of them, and possibly June 30th. We might start later, so I'll post an asynchronous video and then we'll start at like 1 o'clock. I'll let you know. So it's based on a meeting I have those 2 days. Anything else? So yes, there's a lot more. So there will be 2 tests. Wait, let me write down my and everything. So I'm Dr. Prosher, and you can reach me by this email. I'm sure you got it already. I email your addresses that are hooked up to CUNY First. So whatever email address is connected to CUNY First, that's how I'll contact you. And this is my email address, just in case if you didn't receive the email. If you have any communication issues, just let me know and we'll take care of it. My email. And if you need some office hours, if you want to go over problems or something, just let me know via email and we'll set up an appointment. We'll do it through a Zoom chat. Okay? Anything else? You can see the board okay and everything. Everything is okay. You can hear me clearly. All right. You could great. Thumbs up. I like that. Yeah. And then so you can reach me through email. That's the best way, and I respond pretty quickly. Stuck in a house like you, so kind of tended to my computer. So for Zoom etiquette rules, it seems like you guys already got it. Mute your mic if you're not actively speaking, just in case if your family in the background is making noise or something. You don't have to worry about that. You don't need video. It's actually nice to see you guys in video if you want, so I can see your faces. And it'd be nice. I could see your responses from your faces, and it's I'll probably teach a bit better because I can see whether you have an inquisitive look or not. But it's not necessary. but it will be necessary on the test. So for the test, I will need, for the 2 tests that we'll have, we'll have one test around June 23rd, depending on how far we get with the material, and the other test will be on the last day, July 21st. And for those tests, it'll be a 3-part test. It will consist of short answers given on Master in Physics, 2 long answers that I will, 2 or 3 long answers. I haven't decided how long, what type of questions yet, but long answers, and I will hand them out to you or email them to you, and then you'll have a certain amount of time, and then email me back the answers. And then the 3rd part will be an oral part of the exam. So this will run roughly 5 minutes. We got to keep it short. We'll see. And it'll consist of me asking you questions based on the short or the long answer test. I'll go into more detail before the test. So you have to be prepared to answer some oral questions, and I'll help you prepare for that. I know it's not probably not used to it, but I did it last semester, and it was very, very valuable for scoring, and also for students studying for the test, because you have to study differently for the oral exam, and I think it adds a lot. And I get to know where you're at, and we get to actually speak in person one-on-one, which is nice. So the test will consist of that type of format. The homeworks will consist of problems given on Master in Physics. Please sign up for it. I think, I don't know the exact price of it, but it costs like $50 or something like that. If somebody already did it, if they could just type in how much it costs into the chat room, that would be great. Yeah, 70. Okay. Yeah, I thought it was around there. Yeah. Do I have a link on Blackboard for what? I think you can get the cheaper one. I don't know the different tiers. I'm sure you could just get the cheapest one. I could look into that. Students never. This is the first time I've heard about different tiers for pricing. So they probably did it for the pandemic or something like that. They probably upped the site. They modified the site. What else? Yeah, so the homework will be given on Master in Physics. There'll be 1 homework per chapter. Hold on, that's sorry. And I'll set the due date, and it'll be due at that date. I will, though, you can hand it in late. You could submit it late. I'll take off 20 percentage points per day for being late. Let me think about it. I didn't think about how many points to take off, because usually I do 10 for a normal semester, but since it's condensed, I have to increase the percentage. But it'll probably be around 20 or 30. Generally, I don't mind lateness. It's just that if I feel like if you're not given a deadline, you kind of procrastinate. I know I do myself. And having that deadline is important to keep you up to date with the work. So that's why I keep these deadlines. It's just it's just to keep you guys from letting the work go by and then having it all, leaving it all for like the last week or not. But yeah, so the homeworks will be due what I was thinking was you have, if we do a chapter a day, a chapter per lecture, we'll have a homework, so that means 2 homeworks per week. And what I was thinking is that they will be due on, so the Tuesday lectures, the homework associated with Tuesday's lecture will be due on Friday. The homework for Thursday's lecture will be due the following month, following Sunday. And then the quiz, okay, so actually Tuesday's lecture, homework associated with Tuesday's lecture will be due Thursday night. I usually make it due at 12 midnight. So it'll be due at 12 midnight on Thursday. And then Friday, we'll be given a quiz through Master in Physics based on that homework. So Thursday, the homework is due, Friday is the quiz. And then for the Thursday lecture, the homework is due Sunday night and the quiz is due Monday night. I think that would work out well. If somebody has any issues with this, please let me know. I'm willing to modify. That's not a big deal. And it might be modified based on the material that we covered. So if you have any, if there's any issues that I haven't noticed or anything like that, let me know.
I'm sorry, you said, can I interrupt?
I'm sorry?
I was just wondering, you said
Yeah.
Tuesday homeworks would be due
Thursday.
Friday?
Thursday. They'll be due Thursday. The quiz for Tuesday will be due Friday. Is that clear?
Yes.
Okay, great. Yeah, so the homework for Tuesday is due Thursday, and the quiz is due Friday. You can see that when the assignment is due on Master in Physics. So, and we may have to modify it based on the realities of how far we get with teaching, or maybe something happens where I'll extend it or something like that. That's fine. And then the quizzes will consist of 5 questions, roughly 5 questions, depends on the chapter. And they'll be out of 10 points or 5 points, 1 per question. And you'll have like a time limit on it of like 25 minutes. And now you got to treat it like an actual quiz. So once you start it, the timer starts, and you'll only have that amount of time to complete it. So you have to prepare for it and be ready to complete it in the specified amount of time. And the short answer test, the short answers for the test will be given in a similar type of format as the quizzes. So, and according to grading, if you look at the syllabus, I can open up the syllabus real quick. Just give me a second. Sorry, I'm on my laptop. I haven't accessed my laptop in a while, so my Dropbox isn't updated. I can open up this syllabus later, but I'm sure you all got it. It's on Blackboard, but the way I made the grade is pretty simple. So the quizzes are worth 25%, the homeworks are worth 25%, and each test is worth 25%. Usually I don't make the quizzes worth so much, but given the situation, I think it's better to base your grade over the entire semester instead of having it mainly based on 2 exams given on 2 days. And this will help keep your grade constant. If you had a bad day on the test, you won't get exactly a bad grade in your class, right? So, and then I dropped the lowest homework grade and I dropped the lowest quiz grade at the end of the semester. So there's some leniency with that. Anything else? Any other questions regarding admin stuff? Oh, homework attempts. Yes, you get a number of attempts to answer it. I think I set it to four usually last semester. I have to see what it's set to. But yes, there will be a finite number of homework attempts. Any other questions, guys? Now, yes. Minora, I haven't decided that yet. Let me think about that. Yes, you do need the test. You do need the textbook, definitely. Purchase a copy, a hard copy from like Amazon or another service. I think I've seen them for like 20, 30 bucks. You know, there's PDFs out there that are available. Get one of those. But please get the textbook. What else? Anything else, guys? Okay. It's advisable to get the 4th edition, yes, because that's the version I'll be working out. I mean, you don't exactly need it, but I definitely suggest getting the 4th edition. That's okay. Let me pull up the textbook. Hopefully my Dropbox is loaded. And we can start the class. Oh, guys, Helen, you have a question? Okay. Okay. So let me pin my yes. I'll post it tonight. Maybe I'll make this one due with the quiz on Friday. Do you want me to have the homework due earlier in the day on Friday, and then you can have the quiz due later that night? Do you want to do something like that? I'm fine with that. Maybe have the homework due by 12 noon, and then the quiz due by midnight that night. Okay, we could do that, because it kind of sucks having the homework due on Sunday night. You know, pretty reasonable with that. So, And I apologize if I'm not looking at the audio. My camera is up there, where I'm pointing at, and my computer's down there. So I'm not looking at the camera. Don't take any offense to it. So we just changed it. So the homework will be due at 12 noon on the day of the quiz. And then the quiz will be due that night by 12 midnight. That seems to be a better situation. We'll set the quiz date. Just look at when the assignment is due. So. All right. Whoa, okay, my screen is backwards. Let me correct my screen. Hold on. Hey guys, share links outside of the room. You know, no copyright infringements are allowed. Okay. Okay. So really, so what is physics exactly, right? I'm sure you hear it all the time. Physics, you know, physicists have discovered this new particle, or physics discovered this new aspect of the universe. So what does physics exactly mean? What physics is, so a body of knowledge that relates mathematics to our actual universe, to reality, right? Now, mathematics, you may not realize, but it's actually not based on necessarily what's allowed in the universe. In a very general sense, mathematics is this abstract notion of what we call logic, right? If I have one unit, one hand, and then I add another unit, another hand, this makes 2 units, right? The concept of addition, 1 plus 1 equals 2, or 2 plus 2 equals 4, exists outside our universe. And this is generally how philosophers and mathematicians think about mathematics, right? So this is called the Platonic world of mathematics, where you have these idealized objects or concepts, like a single unit, you know, one hand, and then we have different numbers of these units, and we can add them up, and then add it up in these quantities, right? You know, when you have 1 and 1, this equals another quantity we call 2, right? And this can exist outside of reality. So math. So physics is really a subset of mathematics, and it relates to mathematics that our universe can be described by. So physics really discovers how we could talk about our universe using this language of mathematics, right? And the way we discover whether mathematics, what type of mathematics, or what type of these, what we can call algorithms, like an algorithm is just this operation, like add one number to another number, that's considered an algorithm. Whether these algorithms actually work in our universe. And it just so happens that in our universe, everything, whether in this mathematical equation can describe our universe, it's very steady. It never changes. It's immutable. So once we prove that this type of relationship works in our universe, that will never change, right? We may end up getting some kind of, we may end up realize that that's an approximation to a much more nuanced way of looking at things, just like Newtonian mechanics, the way we describe everyday motion, is just a subset of relativistic mechanics, which Einstein developed, right? So really, physics is a way of discovering how we use the mathematical language to describe things in reality. And it's extremely precise. Mathematics is the most precise language that we could use to describe our universe, right? Now, the way we discover whether these mathematical equations work or what they are in the first place is through observation, testing it out. Galileo, was famous for dropping billiard balls from his tower, and by measuring how fast they fall, you could develop a relationship and test out whether that equation or that theory works, is actually true. So it's just based off of this very fundamental principle of the only knowledge we accept as true is what we could see or measure, really. When I say see, I mean measure, and that's reproducible. So every time we do it, we'll get the same result, right? The way we do this is by limiting variables. So we want to limit the number of unknowns in the situation of variables as possible. So in Galileo's case, where you drop in the ball, you want the ball to be heavy and not affected by wind as much, right? Or air. So you don't use a feather, right? If you're in vacuum, a feather would fall at the same rate as a ball, but because of air resistance, that's obviously not the case. So it's really the simple principle of observing and seeing if it works, and then modifying your equation accordingly, or your theory accordingly to make it fit to what you actually say. And so it's, and once you set a physical law, once you have like the Newtonian laws, it's immutable. It doesn't change. Once we prove something, it's there forever. Unless there was some kind of blunder in the experiment, which happens, and then you have to take back your results. So, let me share my screen for a minute. So you guys could see my PDF now. So generally, a theory is a broader, more detailed model that describes that is quantitatively testable, and through its predictions can be testable. Like Einstein's theory of general relativity was tested by seeing stars bend as you look at them next to the sun, and then you know that indeed gravity affects the way light is moves through space. And then you have a thing called laws, where these are general statements about nature, and these are immutable. These are proven to be true with given that approximation, and it's a very concise general statement, as in Newton's second law. Now, originally Newton's second law wasn't this simple at all. It was a lot more complex, and we'll go into exactly what F is equal to ma if you haven't known it. Then we have a principle, which is an experimentally valid phenomena that's been observed. So like Archimedes' principle, where you displace the amount of water, when you put in an object into water, you displace an equal amount of water on each side, right? That's taken as a principle. It's not a law. And then, so, like I said, mathematics is the most precise language that we have to describe our universe. What the limits are how well we can measure something. So no matter how precisely we describe something in the universe, there's a limit on its precision, right? And that's what we call uncertainty. So uncertainty is an uncertainty in the measurement. Like, let's say if I'm measuring the diameter of something, and if you look at the tick mark over here, it's a little blurry, but it lies somewhere in between 8.8, let's say, and 8.9, right? So there's an uncertainty in it. And that uncertainty would be, so I would say that if it lies between 8.8 and 8.5, the uncertainty will be this, right? I know it's somewhere between 8.8 and 8.9, so I say that it's 8.85, let's say, plus or minus 0.5. So it's either 0.05 above this or 0.05 below this. All right, I'm going to unshare my screen now, and I'll go to the board. So over here, this is just for the video. So 8.85, and then we know that it's within this amount of error, right? And now we'll get to significant figures. Now, significant figures tells us the important numbers the important digits, I should say, in a number. So here, there's 3 significant figures, 8, 8, and 5, right? But that's not always the case. So there's generally